Hello everyone, and welcome to this short training session on wireless traffic analysis using Wireshark. In this video, I'll demonstrate how to analyze both unencrypted and encrypted 802.11 data frames, and I'll explain how the information we see relates to the data link, network, transport, and application layers of the OSI model. To begin, I've opened the provided file in Wireshark. Wireshark is a packet analyzer that lets us inspect traffic at every layer, making it a valuable tool for IT and cybersecurity professionals. So I've started by clicking into the um, frame 8 here, and the first thing we'll be looking at is layer 2, the MAC addresses. So in the middle pane here, you can see a couple options, but I'm going to expand on the IEEE 802.11, and we're going to see a few things listed here. We can see the source MAC address and the destination MAC address found here. And these MAC addresses identify the devices communicating at the data link layer, which is responsible for framing, addressing, and ensuring data can move across the wireless medium. Layer 2 is especially important in Wi-Fi because it determines which device a frame is intended for, because it is, or I'm sorry, before it is processed further. Moving on to layer 3, which is the IP addresses, I can scroll down and expand into the Internet Protocol version 4 section. So you can see that here. And similar to before, you can see quite a few things here, but you can see the source address and you can also see the destination address. These represent the network layer, layer 3, which handles logical addressing and routing. IP addresses allow traffic to move between networks and ensure that packets reach the correct destination across potentially long routing paths. Moving on to layer 4, we're going to talk about TCP ports. So below the IP header is the transmission control protocol section. I'll expand upon that here. So inside we can see the source port and the destination port. Ports are part of the transport layer, layer 4, which is responsible for end-to-end communication, reliability, and session management. Ports identify which application or service each packet belongs to, for example, web traffic on ports 80 or 443. And then moving on to layer 7 is the unencrypted application data. So finally, at the bottom of the packet details, we can see the data or line-based text data section. I can expand upon that here. And I think it's actually just displayed to the right here, but let me see. Yeah, so here you can see the unencrypted data that's actually traveling, and you can view it in this pane as well. But because this frame is unencrypted, we can see the actual application layer content. This demonstrates the role of layer 7, which represents user applications such as web browsing, email, or messaging. Traffic at this layer is usually encrypted for security, but in this case, it is visible. And then we'll continue by looking at an encrypted package. I'm going to scroll down here to 136. So 136 is an encrypted 802.11 data frame. Layer 2 MAC addresses, just like before in the IEEE 802.11 section here, we can still see the source and destination MAC addresses. Layer 2 data must remain visible to the access point in wireless clients. Layer 2 data must remain visible so the access point and wireless clients know how to deliver the frame over the air. And we can get into why layers 3 and 4 are missing. So if you scroll down, you'll notice that there is no IPv4 header and no TCP header. Normally this is where Wireshark would show the source and destination IP addresses in the TCP ports. However, because this is an encrypted frame using WPA2 or WPA3, all upper layer information is protected inside the encrypted payload. So the wireless header remains visible, but everything starting from layer 3 and above is encrypted for confidentiality. Let me see, so if I expand on the CCMP parameters of the WPA2 encrypted data section, you can look hex pane at the bottom. You'll see the scrambled encrypted data, so I'm assuming this is what we're talking about here. This demonstrates how encryption hides higher level information and prevents attackers from reading the contents of wireless communications without the correct decryption key. So just a short conclusion here. In this demonstration, we used Wireshark to analyze both unencrypted and encrypted 802.11 frames. We identified layer 2 MAC addresses, layer 3 IP addresses, and layer 4 TCP ports, and layer 7 application data in an unencrypted frame. And we examined how encryption hides all the upper layer information in an encrypted frame. Understanding how to analyze wireless frames at every layer is essential for troubleshooting, network design, and cybersecurity work. Thank you for watching this training session.